Thanks. So it's my distinct pleasure to introduce our speaker today, Dr. Elizabeth Doran. Dr. Doran's an environmental engineer and a research assistant professor in the Department of Civil and Environmental Engineering at the University of Vermont. Her research focuses on understanding and enabling adaptation and resilience to climate change. Her work seeks to understand change in the underlying physical and social processes of the climate land system and create resilience through application of technical and policy interventions across scales. She employs an interdisciplinary, collaborative, and multi-method approach, combining in situ and remotely sensed observations with advanced numerical modeling techniques. Dr. Doran is also an FAA certified pilot and enjoys running, biking, and skiing with her family. So thank you, and I'll hand it over to Liz.
Okay, we're going to share screens. I'm going to unshare my screen and okay. And so Liz, can you share your screen? Are you able to?
You see?
Yes.
Wonderful. Let me put it in presentation mode. There we go. Can everyone see it?
I think so.
All
there
right.
we go. Yes.
Okay. Thank you so much for that introduction, Jeff. I am delighted to be here talking about Lake Champlain Basin project, that funded project, EPA and WEPIC. As Jeff mentioned, I like to work in interdisciplinary teams, and I am an engineer, so I want to give a whole bunch of credit to the other co-PIs on this project who bring both ecohydrological and ecology experience and expertise to the project team. And also a huge shout out to my summer interns who have been tramping through wetlands and floodplains all summer to collect some of the data that we are going to use to complete this project. Obviously, nothing happens without a whole host of wonderful partners, and so some of them are also listed here as well. So I'm going to start with a bit of project context. The Northeast US, situated where this project is in Vermont, and all of New England really has a long history of significant landscape alteration. So in this picture, you can see that there were very few trees and kind of dense settlements, highly altered stream landscapes as well, as a part of this European settlement that happened a couple hundred years ago. And we're kind of dealing with this altered landscape as part of this project. So we're bringing river corridor and applied river science to bear on how we bring more resilience to this landscape. And I'm going to start here. We have a couple of different lenses that we are trying to bring to this work. The first is flooding. Obviously, flooding is a natural process, but when those natural processes interact with human infrastructure and settlement on the landscape and human modification, we can have real problems. And I'm starting with this one because all of the stuff that I was going to tell you last week kind of changed when we had a Q50 storm in the watershed that we're working in, which is a pretty big storm, and resulted in some pretty significant flooding. So I am showing you, we're thinking about functioning floodplains here, and they were functioning, or they weren't, but there was a lot of water in our system just a week ago. And so we have been in the process of doing some rapid damage assessment to our instrumentation, as well as opportunistically documenting the extent of this kind of major storm event in the watershed. So I will come back to this watershed. What I do want to show you or point out right this second, though, is that you can tell all of the pictures kind of on the outside of the screen are are looking really brown. And then you have this one picture at the bottom where the water still looks pretty dark, even though the whole watershed really had a large storm. The significant erosion processes that happened are carrying a ton of suspended sediment downstream during this event, particularly along the main stem of this river. And in the watershed that we're working, there's a real concern, I guess. The US EPA has designated the entire Lake Champlain Basin that we're working in an impaired watershed for nutrients. And one of the contributing sectors of the landscape is our streams. Obviously, agriculture is also a big contributor, but our stream network and its erosion is also a real concern. So we are thinking through, as floods happen, how sediment is moving through the watershed, as well as kind of the damage potential that exists and the risk to human life and property. And so those two lenses have been the focus of previous research, and what kind of has been missing to date in this watershed in particular, and in building decision-making tools, is the role of in-stream and floodplain habitat, what's growing and living on in these floodplains that might be contributing to the dynamic processes and the resilience of the system overall. So that has been the focus of that is the focus of the project that I'm kind of talking to you about today, while at the same time recognizing that these other two lenses are also kind of coming to bear. So we have some goals for Vermont's rivers. They kind of exist in this departed state, but we'd like to see them transition to places that are kind of minimally obstructed and diverted, that have all these dimensions of connectivity between the floodplains, the aquifers, critters moving upstream and downstream, as well as the connectivity between the riparian systems and the upland habitats. And so the state is, and a number of our partners and collaborators have been working really hard to build decision support tools to help guide the reconnection of floodplains across the state. And we're building this tool to assess, map, score, and then prioritize those reconnection projects across the landscape. And so the work that we're doing now, and that we, our partners continue to do in those, within the context of those other kind of lenses, is really focused on building this decision support tool that can help guide decision making. So what do I mean? On the flooding context, and nutrient sedimentation, some of our collaborators have been building inundation maps using high resolution digital elevation models and trying to understand the different sedimentation classifications for each of the floodplain types. And really the goal here is, this is an example of just one project type, where in the previous slide, you can maybe see right here, this road has created something of a barrier that in a very large storm, these orange and red, the floodwater is able to access this back, this extended area, but during slightly smaller storms, it really comes up against that barrier. In the case where that is a berm that we can do something about, we're talking about kind of lowering the barriers so that floodwaters can access and reconnect with their floodplains, deposit sediment, become novel habitat environments. So we haven't really had habitat data collection in the past. We have some in-stream work happening, and data has been collected on the in-stream habitats. But the project that we're trying to that we're currently working on is really thinking about what is the role of habitats and the things that live and grow in those floodplains as habitats for the for our floodplains. So what we have at the state level is a very coarse filter approach. We're starting on the left and going towards our research on the right. The Vermont Conservation Design Program has done kind of desktop analyses of the entire state and said, you know, all riparian areas are high priority for reconnection. And we're like, great. But recognizing that some areas maybe are more important than others, or that we don't have the resources to reconnect floodplains everywhere all at once. What we are arguing is that we need a slightly more nuanced approach to prioritizing where within the riparian areas are the most important to start. Not to say that all riparian areas are not important, they are, but we need to take kind of a directed approach. And so we're using a natural communities lens, which is for those who are not familiar, and I'm sure many of you are, this is really a way of characterizing particularly the plants, but also the associated animal species that exist within certain geophysical environments. So we're focused on floodplain natural communities, which include both floodplain forests, which I know some wetland scientists don't consider to be wetlands, but really can only exist in wetter and floodplain environments, as well as more typical shrub wetlands, bogs, reed, cattail marshes, those kinds of things. And we're taking that lens and we're using a validation approach. So some of the data that we're collecting is of these indicator species, particularly some amphibians and otters and upland connected species as well, that can validate whether or not this natural communities approach is actually representative of the habitat function that we are assuming it to be across both kind of fixed species, things growing in place, and things that are mobile across the landscape. So we are building hydrogeomorphic floodplain natural communities maps. We're doing all of this work, I guess, first of all, under an EPA approved quality assurance plan, which was super fun to write. And anyway, we're building maps. So we're taking high resolution LiDAR, topographic analysis, and creating these hydrogeomorphic units. And then we are overlaying flood and inundation maps and using those to predict the likely occurrence of floodplain natural communities at a fairly high resolution. We are then collecting a whole bunch of field data to validate both the distribution of those maps and their function as it relates to different species. So we have targeted a Huck 8 watershed that exists within the larger Lake Champlain Basin in the Northeast. Lake Champlain is the sixth greatest lake, and so this is just a small watershed on the southern end of that fairly long north-south water body. It covers a number of towns, and we had 60 target sites roughly every 1.5 kilometers, which is the home range for River Otter. And we installed 49 of those 60 sites prior to the January 11th flood, which I just have to pause and thank my wonderful interns and field team and myself for actually accomplishing that. That is kind of a wild density of sites to have installed and have permission from landowners across the watershed. And we are super excited about this. Of course, we are in the process of going back to all 49 of those sites to check on our cameras post-flood. So we are looking for, oh, and here's just a redo of where all of those previous pictures were taken. So we have a whole bunch of these sites are really on the main stem of the river, where significant restoration and conservation activity has been occurring over the last several decades. So we're hoping to have some idea of the efficacy of that conservation and restoration activity. And where there are some significant wetland complexes. So the geography is fairly varied, and so is the variation in habitat and natural community types as well. So we're collecting information across a number of categories. We're collecting that natural community data at each of these 49 sites. We are collecting inundation data, if we can find all of our inundation monitors, at roughly, I believe, 4 reaches. So we're collecting inundation at the top of the reach and the bottom of the reach. So we have about 6 inundation monitors out in place, so we can really track the hydrograph and how often storm events are able to access the floodplains. So we can get a timing and duration of inundation. And those sensors are really just telling us when the floodplain is wet and when it becomes dry again. And on each of those sites, we are looking for some key indicator species. So we're looking for amphibians, which have a fairly small scale habitat range and require wet conditions, as well as for breeding, as well as some target species, some upland habitats as well. So they need to move back and forth between these wet and upland environments so that they can complete all the stages of their life cycle. And this is a real picture in the center here of, I believe, a green frog that we observed during one of our training days that we found in one of our floodplain pools that was probably swept away. We're in the process of going through our sites again, and we'll start sampling them for amphibians next week. But major storm, the place that we're standing in that picture was definitely under a good number of feet of water during last week's event. So it will be very interesting to see how the mobile species were responding as much as the vegetation, which couldn't really move, but has is definitely showing signs of inundation. At the larger scale, we're looking for otters, which tend to move over a much larger space. Roughly 1.5 kilometers is what we think their home range is. And then we think they can move up to 15 kilometers. So we'll see what we find. We're using otter lures and motion activated camera traps to observe these species, and also hoping to see other large species that are coming down to the water for various reasons. And we'll continue to monitor. We set up all of these sites in July, and we'll continue to monitor them through the end of the year. But I'm going to share a few fun initial findings with you now. So this is a couple of pictures of some otters, actually, and I'll give you a second to see if you can find them. For those of you who are looking at the end of these arrows, you were right. There are 2, well, it's probably 1 otter and 2 pictures of that same otter. We haven't gotten back to this site yet, but this was our upland headwater stream site, I believe. And so the otters are up there. They're in our watershed. Here's a really cute picture of 2 otters looking at something or doing something at one of our sites. Oh, checking out the lure probably, but I don't know why there's 2. They're having a little confab. So we are seeing otters. We are also, oh, and here are kind of the places, generally speaking, where we have seen otter prior to our flood event. So a whole bunch of places we're not seeing them. And this is very preliminary. We have not processed all of our data from prior to the flood. So this is very, very early. But we've also been seeing a lot of other small mammals, things that we might expect: deer, raccoon, porcupines. The bottom right picture is actually of ducklings. And if you thought that was hard to pick those out, we did too. So we are pre-processing our camera images using an AI software that's taking out pictures of that the camera took of vegetation moving or something that was not an animal. And then we're doing a whole bunch of person-powered identification, species identification, to identify the rest of the species that we're observing. So we are hoping to have some more interesting upland species, as well as our otter, to be able to start thinking about connectivity across the landscape. We have seen black bear. We have seen a moose, which I think I also saw driving one night. Hope it's okay. Wonder where it goes. We've seen a bobcat. This is pretty cool. For those of you familiar with the Northeast, we live in a fairly settled landscape, so having big cats around is exciting. So we'll be taking this data. Folks who are not familiar, occupancy modeling helps us understand. We go back periodically over the course of the summer, and we statistically try to understand the observations versus what we think the true occupancy of the species is. And we build probability distributions to try to understand the drivers of the landscape characteristics that are controlling the occupancy. And so some of those things might be land cover. This is an example of a heat map that we can then construct based on the occupancy and those drivers. So probabilistically trying to understand the quality of the habitat, the proximity to good habitat versus development or agriculture, that kind of thing. And use this to help guide our decision making. So a couple of other things are listed here: time since restoration, etc. And so we'll use this to help prioritize floodplain locations where floodplains are highly functioning or highly departed from their functional state for restoration. And we'll embed this in the decision support tool that's also thinking about flood risk hazard and nutrient retention in the watershed, to hopefully help drive decision making across stakeholder groups in the same direction. So we have folks who are obviously very concerned about flood risk. We have folks who are concerned about nutrient and water quality downstream. And we have folks who are, concerned or primarily responsible for habitats and ecological resilience of species. And those are not always the same groups, but we do want as many people at the table doing this work to help restore the function of our ecosystems. And we hope that the research that we are working on will enable the best decision-making possible across the landscape and be transferable outside of our immediate context. So with that, I think I would like to just kind of wrap up and answer any questions that you may have. Thank you so much for all of your time and attention. And yeah, I look forward to hearing any questions or comments that you may have about this work. I don't know why it's still going.
Thank you for that great presentation, Liz. So we can go ahead and get started with the question and answer session. I'll be posing questions to Liz that I've received through the question and answer button to the presenter. So if you forget to ask a question or you need to leave before the question and answer session is over, you can email Dr. Doran at her email address, and she can address those questions later. But let's go ahead and get started. We have one question. Have you considered groundwater dependent fauna and flora as well in your studies?
Not specifically. Although so we started mapping our floodplain natural communities using the Natural Heritage Program's mapped natural communities, and I was expecting, and they were expecting me to focus on maybe like 7 to 9 floodplain natural communities. And when I did some of the geoprocessing intersections, there were like 57 natural communities represented in the river corridors across the state, which was of 97 out of 97. So like 2/3 of the natural communities that are potentially represented in the state. And so some data cleaning will help obviously bring that number down, but the wide variety of communities that intersect with the river corridor, even the mapped river corridors, which don't go into the headwater watersheds that are like less than 2 square miles, there's huge diversity in what we're seeing within at least the river corridors, if not the mapped floodplains themselves. And we obviously know that groundwater is more or less important depending on the natural community type. So in a sense, yes, they are represented in the communities that we're thinking about.
So I have a question. So I was wondering to what extent the recent major and severe floods in Vermont over the last several years have spurred an interest in this kind of work and in floodplain reconnection in general and wetland restoration or floodplain restoration in general.
So I started working on water quality and landscape scale decision making prior to kind of this latest round of major floods, but after the 2011 major floods. So I had 1927 on my original slide. There was some major flooding in the early 19th century. And then 2011 was another major event. And then last year, and then on the 1-year anniversary of last year, we had kind of so the acceleration of these major storm events has definitely been observed and is on people's minds. I was definitely working on the water quality and decision-making side of it, but floodplains and the functioning of floodplains was very much spurred by the 2011 storms. And then I would say that the kind of word on the street is literally culverts this week after last week's event, because culverts were the major story in the flooding and disruption that's happened, and kind of the catastrophic infrastructure loss to primarily private roads, which is super interesting. We have the watershed that we're working in has some very high gradient headwater stream systems on the eastern side of the watershed, and then it has a tributary kind of in the center of the watershed that flows to the north and is fairly low gradient, probably got less water, but is also has a huge wetland complex in it. And I showed you the difference in the coloration of the water during the peak of the storm. And there's also, we're in the process of mapping high water marks at all of our sites. So we'll have a really good idea, hopefully, of the dynamics of the storm and the flood extent across the watershed. But early indications are that the the places where there are large wetland complexes fared a lot better. And that was true last year as well in the major storms. And there's a real push, I think, within the state to emphasize what was working after last year's storm and eventually out of this year's storm as well. And one of those stories is wetlands work. They are sponges and they really do help. And the places that were reconnected after the 2011 storm, after Irene, were also notably less impacted after last year's storm. So there is great interest, and I think the research and river science community and wetlands communities are like, also things are working, and we need to be telling people that story as well, and make sure that they understand that these investments are really important and they're going to help in the long term.
Roy asks, this work is very applicable to issues in New Jersey. Any thoughts on how what you're doing can be translatable to New Jersey floodplains? For example, will your study results be posted to a website and provided in publications, reports, etc.?
Oh yeah, for sure. So we have like funding required reports, but we are also a team of academics that are very interested in publishing this data and sharing our findings as we actually are able to analyze all of this data that we're collecting in publications. The results, as they are helpful, will also be incorporated into the decision support tool that's driving the Vermont Rivers program to prioritize floodplain reconnection as well. It's called the FFI, Functioning Floodplain Initiative. And some of our early models are already embedded in that tool. And that tool is live for both river hazard reduction and nutrient prioritization. So those two lenses are live and being used, and you can go and check out that tool. And we're in the process of adding this, the habitat lenses, both instream, which other folks are working on, and the floodplain habitat component as well, to be able to quantify some of those co-benefits in decision making, as well as kind of driving the different communities to the same table. In terms of the modeling approaches, I'm hopeful that those will also be helpful to others doing similar work in other places, for sure.
How were the hydrogeomorphic units delineated in your study?
So we are using a high resolution digital elevation model. I'm happy to share the reference that we used, and my research collaborators are actually leading this work. So I would really like them to answer this question, but to the best of my ability, we are able to take the digital elevation models and do like points surrounding every point to delineate the contours. And then it really is, there's an art and a science to this. You can do as many classifications as makes sense. The higher the resolution in the geomorphic classification, the more units you get. And so the art is, and the validation with the data that we're collecting in the field, is making sure that the resolution of those categories is representative of the variation in the natural communities on the landscape. So you get back channels that are actually wet and not three different groups, but just one, if that's just one natural community unit. That makes sense. So we're in the process of both deciding the resolution and validating with the data that we're collecting.
One of our attendees asks, how can we calculate the economic benefits of connectivity of floodplains for decision makers?
There are a lot of ways to think about that. The Vermont Functioning Floodplain System initiative is, so in the state of Vermont, we have